So, welcome everybody to this Friday's Backend stream. As you can see, Andreas is back from vacation, totally relaxed, so we can start.
Okay.
Okay, maybe not. Yeah, so what do we want to do today? As wished from Jonas, we want to deploy our backend today, or at least we want to start with all of that. And yeah, and with that being said, yeah, let's switch directly into the code. Huh?
Yep.
Okay.
So maybe one thing, it's the 10th stream for the backend. Yeah. So anniversary. Yay!
Party.
We still need to catch up with the Quarkus version. Today, as Thimo said, we want to deploy our backend. I'm not sure if we will make it in this stream, but we will start working on it. Quarkus, as you might remember from all my praises, is very good for containerized environments, so especially for stuff like Kubernetes. And that's what we want to target. We want to deploy our Quarkus container to Kubernetes. Mm-hmm. If you remember from the past, we have the movie time BFF, and we have also built some GitHub actions, and these create already a container, and you can see here under packages on GitHub, you can find this container, and when you execute this command, you can download this container. Since it's a public repository, everybody can do that. And we want to use this container and deploy it to a Kubernetes cluster that we have.
It's just a second. Can you move your cam a little bit to the other side? Not too much. Yeah, no.
Oh, this is really
perfect.
Close.
So.
Okay. For those who might wonder, what is Kubernetes? Kubernetes is helps you orchestrating your containers and your whole infrastructure. And how it works is basically you can wish what you want, and Kubernetes tries to fulfill your wishes.
Okay. Sounds easy.
Yeah, and it's really it's a great concept. So, for example, when we want to let a container run, our Docker container, we can tell Kubernetes to create a deployment for us. This is an example from the Kubernetes docs. And basically, you have to define a YAML because we want to create a deployment. We create a deployment YAML. And this defines our wish, so to say, what we want to have. We can give this some metadata, the name. This is mainly for us to see. Also some labels. Maybe you want to label all your services that belong to one team or to one department or something like that. And then under spec, you actually define what you want to deploy in such a deployment. Here they want 3 replicas. So they want to not just run this container once, but 3 times. So Kubernetes will make sure when you deploy this, then it will start up 3 Nginx containers. Then we have some other metadata, and then we define the template. Again, this is basically the template for creating these deployments. And in this template, we specify the containers. You can have multiple containers in one deployment that might belong together. So you might have your application container, and then maybe also some sidecars, they are called. So additional containers on the side that maybe do some special profiling or tracking or logging and stuff. So here we define, that's the name of the container, how it will be running later. And we define we want to use this image. This is basically the Docker Hub image with this tag. And we give it, we tell Kubernetes that on port 80, this container will be reachable or will listen. So that's also something we tell Kubernetes here. Yeah, and if you deploy this, then Kubernetes will just create for you 3 Nginx containers. We can maybe just try this out. As a disclaimer, I have not tried this example.
Okay. So this could get interesting now.
Yeah. So, for starters, I have connected to our Kubernetes cluster, one of our test clusters. What you can also do for local development is, for example, if you have Docker Desktop installed, then you can just set one option and then it installs you a Minikube Kubernetes locally. And then you can run your Kubernetes locally as well. This is super good for local development.
Okay.
But since we want to run it in the cluster anyways, I will directly now try it there.
So for in development, you can do it completely local?
Yes. Yeah, you can just start your local Kubernetes cluster. It installs everything you need, and then you have a Kubernetes locally, and then can put everything in there. So we can now kubectl apply. So kubectl is the command line tool with which you connect to Kubernetes. Nginx deployment. And now we have created this deployment. And kubectl get deployments gives us the deployments.
Or maybe I just turn my cam off for some time. Or yeah, that's also.
I move it a bit up. So kubectl get deployments is the way to get the deployments. And there's also other resources. So for example, a deployment now, this defines what we want to have. But from the deployment, Kubernetes automatically creates pod definitions. And the pod is actually what we have defined here. All these containers together, they build one pod. And at the moment, there's one container of one is running in this pod. And you see we have 3 containers here. They all belong to the Nginx deployment. And yeah, and they have different IDs here.
So now we have 3 instances?
Yes.
And what is about the load balancing stuff? Is that automatically done by Kubernetes or?
Not yet.
Okay.
For that, you need to define a service.
Okay.
So a service is basically, maybe we can just do it here. No!
That was the wrong button.
Split right. Then it's not on your your
it's
head.
in the middle. Okay, perfect.
Yeah. So, what do I want to say? So yeah, a service. Service is the Kubernetes way of defining a load balancer. The service, you define it basically the same. When we have a short look here, services. Service. So here, this is how you define a service. Basically, the important part is you use TCP. The port is 80, and so 80 is the port where the service is reachable, and the target port is this. So this is the port on the container, and this selector is used to find the container. So we don't want to use one pod. We want to get every pod that has this label, basically.
Okay.
So if you remember, we defined some
The label was Nginx.
Exactly, the label was Nginx. So if we put this here, I think if you can put multiple in one file. Usually you make multiple files, but for the sake of testing it, so
that would be now Nginx instead of my head.
It's actually app. So
oh,
yeah, it's the complete label, I think.
Let's see.
Let's see. Yeah, the container port is also 80. So apply. We have this applied. You see here, service has been created and the deployment was not changed. So Kubernetes also, when you update it and nothing changes, your wish didn't change, so Kubernetes doesn't have to change anything. And if something changes, then Kubernetes will again try to adapt and make it possible. Kubectl get service. So here we now have our my service, our awesome name. And it has this internal IP and on port 80, yeah. So we could now call this my service, and it would lead to all these 3 pods, and it basically does a round robin by default. Yeah.
Okay, that's easy.
Yeah, that's the basic principle of Kubernetes, and that's really powerful. You can imagine, because you just say what you want. Also with this replicas here. So at the moment, what for example, what you can do, I want more of them. So I say apply pods, and now you see I have the 3 old ones and 2 new ones started. They just started. And if I now change it to 2 and apply again, then you see 3 of them are terminating and 2 continue to run. And you can also define like health probes. And the load balancer can use them to detect if a node is maybe down due to some reason or hasn't fully started, for example. So when your service starts, it first needs to boot up and connect to some stuff, maybe get some config from a remote store or so. This can take some time maybe. And during that time, you don't want users to call this service and the load balancer to lead calls there, because it's not working yet. And only when the readiness probe is okay, then the service will be used. Yeah. So now we want to deploy our service. Now we don't want to hard code this, because so for example, this here, the tag, as you have seen on our GitHub, here we could use always latest, but the problem with that is latest doesn't change. So when you want to deploy a new pod, how would Kubernetes know there's a new one? Because you just told it to deploy latest, and if you update it, it still says latest, so nothing changed.
Okay, so it can't recognize that it changed.
Yeah. So what we want to do is we want to use this full commit tag. And when we update this, something changed, and Kubernetes will try to load that. So we would need to basically to template this here.
So some kind of variable. Or...
Yeah, use variables here. Then also you might remember we have the API key for the MovieDB. And if we look here in the application properties, we have the database host, port, database name, and so on. So we need to specify them. You can also specify like environment variables here, like this, and then you can define some var and value hello. But again, we don't want to hard code this. We want to specify dynamically, and maybe even have, if we have different environments, for example, we have a development environment, a production environment, then, for example, the host might be different from the database, and username and so on might be different. Okay, so that's that. Let's, oh no. Let's first kubectl delete. Okay. And now you see it's also, all of them are terminating in, and
okay, that takes some time.
Yeah, they have been told to shut down, and
okay,
they will shut down. Okay. So for this templating, because everybody has this issue, there's actually a neat tool for that, and that's Helm. You can get Helm. No. This Helm. This is basically, yeah, like it says, a package manager for Kubernetes. So you can also, you can define how your deployment works, and others have also defined their deployments. For example, you can just use a Postgres deployment. There's a Helm chart. They are called Helm charts. There's a chart for it, and yeah, there's a lot. And it's only on the public repository. Postgres. They also have something for Postgres here. What I usually use is from Bitnami. They also have a whole database of Helm charts. Yeah, and we also want to use this.
Okay.
So what you can do with Helm when you have it installed. Does this Helm also protect me when I fall with my bike?
I don't think so.
Not sure. Maybe you can create a template for head protection, but you have to specify the correct parameters, I guess. Maybe just wear a normal bike helmet. It's probably best. Helm init or something like that. Helm create. Helm create, and you have to give it a
name.
Yeah, but let's first create a directory and go into that. And create, and we name movie. Movie time BFF. So
okay. No, it's creating more than one file.
Yeah, it creates more than one file. So we start here. This is the chart YAML. Basically, this is the metadata for your chart. The name, this is the API from Helm, which version we use, the name of the thing. Here you can rate some
more description. Awesome backend.
Movie time chart. So we don't need that. It's an application. You can also define a library but yeah, at the moment we only want the application. This is the version of the chart. So if you share this with others, then you can increase the chart version when something changes, like you normally version stuff. And then this is the version of the application. I don't think we even have a version yet. Do we have one? 1.1 snapshot. I don't know if it survives the snapshot thing. Let's call it like that. Okay, so that's basically just metadata for now. And then we have a values YAML. This defines stuff that we want to configure. Okay. Here we have a directory templates, and here are some templates in there. And for example, you see here the deployment YAML. That's basically what we just had written ourselves. It's now generated and much more complex looking, but it's basically still the same. It's just this super ugly beard, or however you call it, with this mustache braces here to basically tell this is a variable that it should be filled in.
Okay.
And you can include here some functions that are even more ugly. And yeah, but that's just how it looks like. You can also do some ifs and else's and so on. All of that.
So basically for every entry in there, there is a variable or something which is used.
Yes, yes. So some stuff is hard configured. For example, the liveness and readiness probes here, which is a pity because we don't have them at the moment. So I will disable them directly. Otherwise, Kubernetes will try to reach our server there. And when it cannot reach it there, then it will say, oh, it's broken, let's restart.
Okay.
But we don't have them, so no luck there. Yes, so we can now configure our deployment, our service, our ingress, which I will come to later, from this values YAML. Okay, so let's get started. First thing, replica count. I think it's okay if we start with 1. Then repository. Which repository do we want to use?
So that's basically now the GitHub repository, right?
Yes, and it's basically that part. We don't want Nginx repository, we want that. For now, I will define latest here. But we can later override any value from here.
Okay.
This will be important because we basically just define defaults.
Okay. So latest as default, and then we specify
the real
the
value
specific
later.
version later on.
Yeah, because later we want to run it in CI, and CI will then know which is the Git version and the tag and so on. So it will then override with a parameter when it calls Helm to install this chart. Then it will say, okay, but for tag, use this.
Okay.
Image pool secret, we don't need that. This would be if you have a closed Docker registry, your private one that needs a secret, then you can put this here. Name override, here you can change the name of your chart. But we just given it our name, so that's fine for me. No need to use that. Service account is something about security stuff. We don't need to worry about it at the moment. What I want to use is the service, and later on the ingress and the resources.
Okay. So
I will just move this a bit up, the relevant stuff, and move the other stuff down. So here we define the service. We don't have to define much here. It says this is the port of the service. Now I'm wondering, yeah, but Quarkus is usually running on port 8080. So how does the service know it should use port 8080 on the container? That is actually something that is not configurable.
So you have to change the template now.
Yeah, you have to change the template. We could also create a new variable, but for now, let's just say, so here, you remember we have the template from the deployment YAML, then the spec. In there are the containers. We have the movie time BFF container. When it's this gray, it's actually a variable, and it's just showing the value. And then we define here ports. The port is called HTTP. That's not a protocol, it's actually the name and the container port. And here in the service definition, we define the port for the service. So users of the service will have to use port 80. It will go to HTTP port, the name on the container, and it will use the TCP protocol and whatever.
Okay.
So we continue here. So here's actually not much to do for us. Ingress we will come to later.
Okay. So you explain it later what it is.
Yeah.
Okay.
So let's try to deploy this. helm
Okay.
upgrade. And then we need to give it a name. This is the name of the installation of the chart, basically.
Mm-hmm.
So the chart has a name, how it's called, but this is the name. Yeah, I mean, you could install the same chart multiple times. For example, the Postgres chart,
Mm-hmm.
you could install your Postgres for your key cloak, for your application, for whatever.
Okay.
And this is basically the name that you give this now. And then, of course, we have to say, use this chart in this directory here, this one.
Upgrade failed.
Yeah. So what I did is I used upgrade.
Mm-hmm.
There's also install.
So the first time you have to use install?
Yeah, you can. Or you use this, which is much nicer because this works in both cases. If you use install, then it doesn't work when it's already installed.
Okay.
So with this, it works in all the cases, which is especially good for CI.
So this basically checks if it's already installed, then it does the upgrade, otherwise it does the install.
Exactly. So now we have been, there has been printed some, message, which is basically what you can configure here in the nodes. At the moment we don't need that. But yeah. Okay. So Helm, uctl get pots, and we see our movie time BFF.
Error image pull.
Awesome.
Okay, so maybe it's not running.
No, it's not running.
Yeah, it can pull the image.
Yes, and that is interesting.
Maybe some kind of access rights.
Did I not copy
this?
It's
a public repository.
Correctly.
Maybe it's the problem with late. No. It's not.
That's awesome. Because that just worked a minute ago. Upgrade, of course. So what we can do to get more details is describe pod backup pulling image unknown fail to pull and unpack image fail to what?
Fail to resolve reference.
Unauthorized? What? Why? Isn't this public?
I don't know if the repo is public, but this is the I don't know. It's not public.
It's not
Thanks
public?
for the info.
Where?
In chat, they said it's not public. Okay, does anybody know how we can change this?
The repository is public.
Yeah, but not the image. It seems like that's private.
You guys cannot see it? Maybe it's too old or so?
You need image pull secrets after all.
I just...
Organization settings.
Yeah, but I just did this. Can we... How can I just trigger a run? Awesome. Oh, I don't want a new one. Rerun more jobs.
Yeah, but the CI is basically not. I think,
yeah, maybe
I think the CI can access it, but your not in public space, so I don't know what we have to configure in the organization settings. So
inherent access from source, danger zone, change visibility, public.
Yeah, but what visibility is that?
No.
You can. Yeah.
Okay. Okay. I did test it with my own repository, and
there you
I forgot
have
that here there was a problem. Yeah, I remember now. So good thing we have movie time reference, movie BFF reference. So that's basically the same code.
So, but your own repository.
Yeah, it's just in my
it's
own.
not in the organization now.
Yeah, it's under my
Okay.
GitHub account, and that one I made public. I just forgot again.
Okay, so we have to change the URL.
Yeah. Sorry for that.
Yeah. But thanks for the help. Game dev is pain. Nice name.
No, not pull. Upgrade. So then pods. Now you see the old one is terminating, the new one is already running. And now we can get the logs for this pod. And you see
Fail to load config.
Fail to load config, yeah. It doesn't have
the API key.
The API key is missing.
So we have to inject it via environment variable.
Yeah.
Okay.
Exactly. And in Kubernetes, there's two ways you can define config. There's the config map, which is usually used for just config, and there's secrets, which is basically the same, but has a different name, so you can give it different access rights.
Okay.
So in Kubernetes, you can manage who has access to what, and maybe your developer can access the config map, but not the password.
But not the secrets.
Yeah.
Okay.
So we can define such a secret here. Secret YAML. And basically what we need is the kind is secret. We have again metadata. I basically copy this from here. The metadata. This is just so everything has the same name and labels and stuff. This is important for Helm to be able to delete later on the stuff again and so on, and to know which stuff belongs to it. So we want to define a secret, and if we check the application properties, how should it be named? I will name it now like I want to use the variable later. You don't have to do this. You can also later change the name of the environment variable that you inject, but I'm lazy. I don't want to do it twice. So just do it right in the first place. And now we can see, for example, here. Oh no, I will. And there's some specialty to secrets. Where did it go? Ah, yeah. So again, this syntax is for injecting some config. We want some config from the values. We want to name it config. So if we start here,
but we don't have to paste the key in here now. Huh? If so, just tell me.
No, I won't.
Okay.
I thought of that.
Yeah, just to
be safe. Let's call it configure. You could also just not say anything here, but I want to show how it looks later. So we say from the values from config, from MobiDB service, we want to get this. When you click on it with IntelliJ, you directly get there. I think you need a Kubernetes plugin for this to work. Then there's a specialty in secrets. You need to base 64 encode it. This is mainly because secrets tend to contain a lot of special characters, and YAML doesn't like special characters.
Yeah.
So it's actually a good thing. There's also a possibility to say string data. Then you don't have to do the base 64 thing. Then you can just, then it does this base 64 thing for you. But if it contains special characters, then the YAML breaks before it gets to encoding it.
Okay.
So yeah, just do it this way. And then we also quote it just to be sure. So it's basically this is piped into here and piped into here. Okay. Now when we run this or create this, we can now get secrets. You see some secrets here. This is something from the account, from the service account. We don't need to worry about it. This is our secret. It's called like our installation. If you remember, we named it the same way, but we could name it differently, and then this would be the name there. That's the nice thing of using this part here. It will adapt to the name that you give it. So we can get the secrets, and if we go to edit secret, then actually the editor opens, and we don't see any secrets. Or here, up here it is, and you see it as data, and this is our
encoded one.
base 64 encoded configure me, and that's how it would look like. This is not encrypted. This is just base 64 encoded.
Okay, so you can decode it.
I can decode it now. Okay. So this is also it is called secret. This is not secure by default. It can become kind of secure if you only allow certain people to access secrets. Then if you only allow your super admin to access the secrets, then all the others cannot see the secrets, but they cannot see the whole file. They cannot even see something when they do this. Then they see nothing or get an error or something.
So basically everybody who has access to that file
can also see it.
Can also see this, all the secret stuff.
Yes. So just to be aware, the only security is if you add the role-based authentication and limit the roles. But still, it's good to separate it in secret and config map, then you also know what it is. Now we have to use it, because until now, our container has not been told anything about this. It's just, we just said there's a secret. So we can do this in the container. We need to tell it. And you can say, either you could say env, directly define the environment, but you can also say environment from secret graph, and then we can use the name of this name, and then we can use the name of the secret, and the name is again this template here. So this will tell Kubernetes to inject the whole secrets file into this container. And the name is what the name is of the environment variable, and the value will be the value of the environment variable.
Okay.
So upgrade. Now we can do kubectl get pods. Yeah, it has changed the pod. The new one is starting, and look into here. Then you see a different error now, because yeah, the connection is refused. We have not configured a database yet. But at least the movie API key has been supplied. You can also do like this, and you can edit the pod. Then you again get this view here. But keep in mind, editing a pod does not really have an effect, because when you change a pod, a new pod would be created. And then it's again using the deployment config. So the deployment is the master. If you really want to change something on a pod, you have to change the deployment.
Okay, and now for what use case is that?
This is now just to tell you...
Just to see all the stuff?
Yeah, so this is basically what Helm is generating. And here you see our environment from stuff. We want to get this. And let's see.
So basically that's read-only, or should be handled as
in that
read-only.
case, use it read-only. You can also do describe, then you get more infos. And I'm wondering... No, it doesn't explicitly list the environment variables. Okay. So we have that. Now we want a database. Where do we get a database from? So in general, when you have when you use a cloud provider like AWS or Azure or so, then they also offer you special databases. They maintain them, they make them super scalable whatsoever, and it's just you pay and you don't have to care. But on the one side, locally, you don't have them. So locally, you probably, when you want to use the Postgres again, like we did. And also, if you have a small project, you're just starting or so, you might want to just run a Postgres in your cluster. Keep in mind, there's no backup, no security at the moment. And if you use these real services, they do all of this for you. It's not running a database, is not just deploying a container. I mean, it starts and you can use it. And for testing, it's okay, but there's no safety net and no guarantees. So only do this for testing.
You have to configure everything by your own.
Depending.
If you want to do it like that.
Yeah, if you really want to do it, then you need to put more brain into it. But also, then you need a different storage and so on, because at the moment in our cluster we have virtualized storage. So there's a layer in between, which makes it slower, and this is pretty bad for databases and so on. So for our use case, it's more than enough. But if you would want to use it in production, don't do it. Buy a service that's probably cheaper. Or you need a team of admins that really know their business. So what we can do is we can add another chart as our dependency. So I already talked about this Bitnami Postgres chart. What we need to do first is we need to tell our Helm that it should look here in Bitnami for charts. So you can add other repositories to your Helm.
And that contains the definition.
Yes, this is basically just
so you basically say the Helm now, okay, you have your basic repository where you can look. And additionally look also at this one.
So I have a couple for other projects. Some projects have their own repository. For example, there's for Ingress or MinIO, which is an S3 storage. They have their own space where they have their Helm chart. Then also, if you have it already, then it's always good. It's basically, if you know apt also from Linux package manager, it's same update first to have the newest versions available. So when we click here on README, we get to the Bitnami GitHub repository. There's if you want to see all of them, there's like a couple.
Okay.
They also have Kafka and so on, which is working really good. So if you want to run it locally or use it for testing, then that's also really good. So it's always good to have a look here. But we want to look at the Postgres. So what they basically here you see all the parameters, and it's
a small amount.
Yeah, it's a small amount. The good thing is most of them you don't need. So you can configure everything if you want to, but if you don't want to or don't need those features, then just use the default stuff. So there's actually not so much that we need to configure. But first things first, we want to add this chart as a dependency. So in the chart YAML, we can define dependencies, and this can now have a name. So this is the name of the chart that we want. You see there's a couple of sites where you can get a Postgres chart. They are all a bit different, and one might fit you more and one less. But I want this one. And now you can, oh, no, that's not a version, that's the repository. And the version is this. And I think there's 11.6 something. So let's patch version, it's fine to upgrade.
So now it gets the latest one.
It gets the latest patch version. So this way you include security fixes, for example, which might be very interesting depending on what you have. This database we will never expose to the outside world. It will only be reachable inside the cluster. So it's not that threatened, but still, or if they add some bug fixes also, you will get it. But only when you update the chart and install it.
Okay.
Also, we can give it an alias. So this is our movie database. You can use like a dash here, but it will later be very, very annoying. So we won't use it here. Okay, so now we have told it that we want this. Now we need to say Helm build. Was it Helm build? It might actually be what? Build and of course movie time. Let me Google that. Dependencies. Who would have thought that it's called like that? Yeah. So it's now downloading the chart, and it put it in here. Actually, the chart that it's using, and it has now also created a chart.log file. This is similar to if you know Node or TypeScript or web development with JavaScript
it's
and
also
NPM.
on iOS side when you use Swift Package Manager, you get
a log file. Yeah.
So
this really says this is the version of the library. If you want to update this, then you need to dependency build again without the log file, or maybe there's also an upgrade.
Okay.
Yeah. Don't remember by heart. Okay. So we have this in here now. We can also have a look into here. This is basically set up like ours. There's a chart YAML. It has some category versions, names, whatever, maintainers. So you can put a lot of stuff in here. has a log file, a values YAML. So here are all the configs defined with a lot of comments. And in here you have the templates. For example, you have the secrets. You can even run this in with multiple read pods. So if you scale Postgres to have multiple pods, then you can have one write pod where all your writes go and multiple read pods, and they synchronize. So this chart can also handle this if you activate it. And it also includes some subchart. This is a common chart that all Bitnami stuff uses. So that's basically that. But we just want to use it. So we have given it an alias, if you remember, a movie database.
So now we have to say that this.
Yeah, so what we want to configure here, basically.
Okay.
And Intelli helps me.
And now you can define all the variables.
Exactly. I can override everything from their values YAML.
Okay. So
in their values YAML, they have defined the defaults, and I can override it.
Okay.
So one thing what happens? We definitely have to override is the authentication stuff. Yeah. So in here we have a Postgres password. Again, I will write some values here, so it deploys when we test it, but in your CI you would set some real values from CI secrets. Yeah.
So this is my awesome password or something like that.
Exactly. Username. It's username. Password. The good thing is this database is not exposed to the world, only reachable inside the cluster, so nobody will directly hack us. But again, like I said, in CI you would inject some real passwords and stuff, and also depending on the environment, use different ones and so on. So yeah, this is for the admin. This is the normal username and password, and this is the database we want to create.
So that's the minimum set you have to define.
One more thing, and this is you need to service ports Postgres, and you need to define which port you want. I use the standard Postgres port here. Okay. So if we just deploy this, great. See, oh, it worked first try. Okay, pods. So you see, here's our movie time BFF movie database. So it stacks the names, or it's a hierarchy of names.
So basically our name, then the name of the database, and if there were also another dependency, then it would get in the next position. So.
Yes, exactly. And one difference you see here is here you have an ID, here you have 0. This is because this is not a deployment that is behind it. There's a stateful set behind it. A stateful set is a bit different from a deployment. The deployment is stateless. So our movie BFF, it doesn't care where it's running. So in the Kubernetes, you have many servers where your stuff can be running. And our movie BFF, it doesn't care where it's running. It can be moved around. It has no state. But your database, it has a storage. And usually you want the storage to be on the node itself, where it's quick to reach and not transfer data over the network. So that's why it's stateful, and it should be always deployed on the same node again. That's the difference. But usually you should not or you use it only in these special cases. Usually you should try to have only stateless stuff, but sometimes you cannot avoid it.
Okay.
Like when you really have to store data.
Mm.
Okay. So is it up? Yes. Database is up. Awesome. We can also see get service. We also have the database service here. That's the one we care about. Now there's one thing I don't really like, this nested naming here, because it will make our life a bit harder, but let's see that. So we need to pass the secrets to our service.
Mm-hmm.
So we create some new secrets here, and what did we call them? Database password. Oops. Secret. And we basically do the same. And now we can movie database of password. Okay.
Mm-hmm.
And as I said, there's config map for config and secrets for secrets. So let's create the config map. It's a config map. This opaque thing is not available. We don't need this base64. And we want to have the database username, not this, db host port, host. So host is something special.
Mm-hmm.
The host that we want to reach would be this service name. Okay. So now I don't know an easy way to get this service name. Because it's consisting of the name of my service or my chart here and the name of the subchart, but I cannot get some stuff from the subchart. So either you hardcode this, which I really don't like, or we can override the name here. Full name override and just call it movie time database.
That's why you can override the stuff.
Yeah. And this will make it that this name here is now movie time
database.
Yeah.
Okay. Because I was wondering why you want to override the naming stuff. Okay,
yeah.
Now I know.
Yeah, also this full nesting might not make sense always for you. Full name override. Oh, wrong file. Database, full name override. Then we also need the db port. This was in service. So I'm just referencing all the other values there. Username and the database name. DB name. Database. Okay. Any clarities?
So that's basically the basic setup for this stuff.
Yeah. And again, like we did before with the secret, we also need to tell the container, please load this stuff. Or we need to tell Kubernetes to give the container the stuff. So we
a normal ref or?
Yes, not a normal ref, a config map ref.
Okay.
And the name is the same.
Okay.
Because it's a different kind, you can give it the same name.
Okay.
And Of course, you can also do something like this, but I don't see a need. To get it, you need to get secrets, and then you only see the secrets. So you will never have a conflict with the names. Okay. Let's try that. Get config map. Yeah, you see there's 4 entries in there. And if we edit config map, then you see here the values. And you could change it now. Here, save this, close, and then it's changed in the cluster.
Okay. Until the next deployment.
Yes, because in the next deployment,
it's
overwritten again. Yeah. So, the BFF has started again. Logs. Something crashed. Connection refused. Movie time database 5432 refused. Okay. Get service. Movie time database. What does the database say? It's up and running on 5432. Okay. I think I know what's wrong. When you look here, the age of both is exactly the same.
Yeah.
So they started at the same time. So Quarkus is really fast in starting up. So it really quickly tested if the database is there.
And it wasn't available.
It wasn't available.
Okay.
So let's just delete the pod. Again, I will delete this pod, but the deployment says I want to have 1 pod running. So Kubernetes says, oh, there's none running, but you say I should run one. So it starts up a new one.
And how can you do that then later on a real system? So when you need a special order of starting the pods,
I think there's even stuff to configure it.
Okay.
But what you could do here is just, which we should in general do, is define the readiness probe, the liveness probe.
Okay, and then you can check.
Yes, so we would define these 2 probes on our BFF, and the liveness probe tells if a service needs to be restarted.
Okay.
It's that. It will not be able to recover. If it's not ready, then it's able to recover. But if the liveness probe fails, it's never going to recover, and Kubernetes will kill the pod and just start a new one.
Okay.
So this would be the way. Thing is, Quarkus needs the database when it's starting up. When the database connection is lost while it's running, then it's not that bad, and you can just wait for it to come back.
Okay.
Then it will only fail the readiness probe. But we will probably next time add the probes as well. So we have our new pod running. You also see this has a new ID. Logs. So no errors. Awesome. Now there's only one thing left. I need to supply a proper API key for it to work. Oh, there's one more thing after that. But I can do that by, I told you about, you can override all these variables here. And you can just do this with, oops.
Should I hide your screen or something?
I'm prepared.
Oh, okay.
So here you can just say movie database. No, it's not movie database, it's config movie db service API key equals, and you can just do set at 1,000 times. And I can use my trusty environment variable, which is exactly named like this here. So you don't get to see it. So get pods. Oh, there's one. So you see here, I upgraded the chart, and when we look at the secret, we see this secret is old and it doesn't tell you when it last updated, unfortunately. But it was just updated because I changed the value of that secret. But the pod here, it's still old. It hasn't restarted.
But does it use the new value or the old?
No, it doesn't. Okay. Because environment variables are only loaded at start of the pod. So what we would need is for the pod to restart. So unfortunately, that didn't happen now. Why does it not happen? Because the deployment YAML, it didn't change. We have only written this here, and this name here didn't change. So nothing here changed. So Kubernetes cannot know that it does not look into everything that you import here and stuff. So it cannot know that that something has changed. This file didn't change, so it will not update. But there's a trick for situations like that. And this is, you can create an artificial change. And this is, we can add something to the annotations here. We can add some annotation. So basically, it doesn't matter how you call this here. I just call it this way so it's clear what it means. But the only thing we have to do is when the secret or the config map changes, we need to make sure this deployment YAML also changes. So what we do is we calculate a hash of the content of that file after it has been templated.
Okay. And then when the content changes, the hash changes, and then it's...
The deployment YAML has changed, and then Kubernetes starts the pod again.
Okay.
Yeah, hacks.
Yeah, as Jonas says, but that's a hack, right? That's not
That's the way it's intended to be done.
Okay.
I mean, it feels hacky, definitely.
Yeah.
And at this moment, you're happy to have Helm, where you can do stuff like this, templating it.
Yeah.
But to be honest, there's also no real good way for Kubernetes to know. It would have to check everything, and this can become really big.
Yeah.
This way, you can explicitly tell it.
Okay.
So I have done this for the secret and for the config map. So whenever they change the next time,
then it will
redeploy. So now the pod will restart because we added this the first time. So pods.
So now we have a real change in that YAML file.
Yes, exactly.
And now when
we change, for example,
something in that config YAML file, then it also should restart.
When we no, I did overwrite this. Yeah, so let me just change it here. ABC. So you see, here's a new one creating, and the old one is currently still running because Kubernetes waits until the new one is ready, and then only it shuts down the old one. So you have a smooth transition.
So basically, the new one has to
be ready
active or running.
Yeah.
And then the other one, as you can see now.
Yeah, actually not just running, but also ready.
Okay.
And ready is again defined with the Readiness Probe that we still have to add. At the moment, we don't have one, so running is ready.
Okay.
But it could be that the container is running, so basically it's booting up, but it's not ready yet. In that case, it would not shut down the old one yet.
Okay.
So for example, it could also happen you made a change and the container crashes during startup. Then it would never reach the ready state, and the old one would forever be running, and the new one would be in maybe restarting and so on. And you could, basically you don't have a breakdown of your service, but it's still working.
Okay.
And also, if you have like 10 pods running in parallel, then it will start 2 new ones and kill 2 old ones, and then start the next 2. So it's doing a rolling update, and you can also configure this, how much
Nice.
rolling update you want. So now we should have, again, the wrong secret. Now, again, the right secret. Thing is, we cannot reach this, our service from the outside world at the moment.
Okay.
But obviously, we want to do that. And that's where the ingress comes in.
So the question is, should we do that today or the next time? Or
maybe that's a nice cliffhanger.
Yeah.
Next time, we will be reachable from the outside world.
Yeah. So now the normal question to the chat. Do you have any questions till now? So,
yes, half a while.
So if you want to know how it continues here, then
in 2 weeks.
In 2 weeks. So let me change to the other scene. And yeah, so let's just wait some seconds if there are any questions. And yeah. Otherwise, we will end the stream then. And yeah, the next YouTube video should be online by now. So if you want to watch more, then you can rewatch the last backend stream. And yeah, okay.
One thing I just noticed, Flexus subscribed again, or?
Resubscribed. 6 months.
6 months.
Thanks. I hope he is still there. She is there.
And Lensman cheered some bits. And
I am, perfectly. So thank you for the subscription. And yeah, then
see you next time.
See you next week. Or
have a nice
next
weekend.
time. Yeah. Bye-bye.
Bye.